सो टॉकिंग ऑफ फिनॉल्स, फिनॉल्स जो हैं वो इस तरह के कंपाउंड्स होते हैं जहाँ पर OH जो है वो एरोमेटिक ग्रुप से डायरेक्टली बॉन्डेड होना चाहिए, एरोमेटिक रिंग से डायरेक्टली बॉन्डेड होना चाहिए. इफ इट इज बॉन्डेड टू sp3 कार्बन लाइक दिस, okay, then it is not phenol, it is alcohol. और अगर अल्कोहल और फिनॉल आइसोमेरिक हैं तो उनके बीच में आप फंक्शनल आइसोमरिज्म बोलेंगे. ओके, दे आर फंक्शनल आइसोमर्स ऑफ ईच अदर. फिनॉल्स को हम कार्बोलिक एसिड भी बोलते हैं. फिनॉल्स आर आल्सो नोन एज कार्बोलिक एसिड्स, राइट. नाउ द एक स्लाइड है जिसमें जनरल या कॉमन नेम्स ऑफ कुछ फिनॉल्स आई हैव एडेड. यू कैन यूज देम फॉर रेफरेंस. Now coming to physical properties of phenol. Phenol room temperature पर solid होगा क्योंकि इसका melting point जो है 43 डिग्री सेंटीग्रेड है. जब गर्मियां होती हैं तो थोड़ा लिक्विड थोड़ा सॉलिड रहेगा. सम पार्ट आपको उस बॉटल में जहां फिनॉल रखा है सॉलिड में लैब में वहां आपको लिक्विड भी दिखाई देगा. बॉइलिंग पॉइंट इज 182 डिग्री सेंटीग्रेड. अब इंटरेस्टिंग चीज ये है कि कल हमने ग्लाइकॉल का जो बॉइलिंग पॉइंट करा था, ओके, एज फार एज आई रिमेंबर हमने कल किया था, इट वाज समवेयर अराउंड 198 डिग्री सेंटीग्रेड और सो. ओके, अब ग्लाइकॉल से कम है फिनॉल का बॉइलिंग पॉइंट. इथेनॉल का जो कल हमने किया था, इथेनॉल वाज 78 डिग्री सेंटीग्रेड एंड ग्लिसरॉल जो है वो रफली 290 डिग्री सेंटीग्रेड के आसपास था. तो अगर हम देखें रफ तो ये देखो कि फिनॉल का बॉइलिंग पॉइंट इज लेस देन ग्लिसरॉल, लेस देन ग्लाइकॉल, राइट. भले ही उसका मॉलिक्यूलर वेट काफी हाई होगा बट स्टिल इट्स बॉइलिंग पॉइंट इज लेस. टॉलिन से इट इज मोर. स्पेसिफिक स्मेल होती है, slightly soluble in water, corrosive nature. It is acidic to litmus, so you will have the litmus test positive, that is it turns blue litmus red. Pure phenol or fresh sample is colorless but it is easily oxidized to light pink. इस तरह का इसमें जो है कंपाउंड बनता है जो लाइट पिंक या कई बार सॉलिड स्टेट में तो वो ब्राउनिश सॉलिड भी दिखाई देता है. पिंक और ब्राउनिश सॉलिड, this compound is formed and this is pink or brownish solid. Okay, now these all compounds by air oxidation gets converted to this compound. All compounds, this all get converted to this compound, pink or brownish solid. Dipolement of phenol, sorry, para जो है हमारा दिस डाइहाइड्रोक्सीबेंजीन, इसका डाइपोलमेंट 0 नहीं है बिकॉज इट इज नॉट अ लीनियर सेटिंग, है ना. OH ऐसा भी हो सकता है एंड इन दिस अरेंजमेंट म्यू विल बी नॉन जीरो. yes, there is a possibility that one of the arrangement is this and in this I can have a dipolement 0 जहां cancellation हो सकता है but not for this. Okay, so that is why I cannot say that dipolement of para dihydroxy agar benzene hai so it is going to be 0. It may or may not be 0 for different compounds I am talking. And same will be applied for trans alkene whenever we have such compounds which are like, see, opposite tendency groups are attached, so dipole moment is added, so mu is going to be non-zero. And in fact मैं ये भी कहूंगी कि mu of trans will be going to be mu of cis because here it is added, whereas in cis it will be relatively resultant की बात की जाएगी वहां. ठीक. Preparation of phenol, if we talk, first is from Dow's preparation of phenol, which is the historically important. Questions में it is still important but not commercially important anymore. It was used in past. Now see why it is a thing of a past, because the temperature 623 Kelvin, right, and 320 atmospheric pressure. If we have this high pressure, then definitely the conditions to maintain them is very, very risky. Okay, and if the situations is so risky, then what we'll have is a very risk prone industry. And उससे क्या होगा? If we'll have, I have someone as Amit K. Kindly mute yourself. If you have any doubt, please ask. Otherwise, mute yourself. He seems to be gone. Okay. No, he's there. Okay. Okay. Thank you, Amit. If you have any doubt, raise your hand and then we'll discuss. Okay. So I was telling that from halobenzene, the first method is this Dow's process. Now, this is a benzene mechanism which is not in JEE syllabus, but remember it is not a SNAR. ये reaction SNAR से नहीं होती. It is not an SNAR reaction. It is a benzene mechanism reaction. And both for SNAR and benzene, the order is PHF, Cl, Bri. For SN1, SN2, I, Br, ClF. Opposite, but for SNAR, the order is FCl, Bri. Take as we introduce even one nitro, ortho, and para to this Cl or any halogen, then the reaction shifts from benzene to SNAR, and conditions become much easier. You can prepare phenol from benzene sulfonic acid. First, you prepare sulfonic acid and then heat it with NaOH. But conditions basic to phenol nahi banega, it will be phenoxide, so followed by H plus, phenol is formed. You can have it from diazonium salt. Prepare a diazonium salt and heat it with water. You can have phenol, right? Most important is hydroperoxide method of phenol preparation. This is today's industrial method of phenol preparation. Please note it as very important. इस पर questions आते हैं, बहुत अच्छे आते हैं. So let us do this reaction. Now what happens? The reaction is after the cumene is formed. This is cumene hydroperoxide, and hydrolysis of this cumene hydroperoxide gives phenol. But how to make cumene? Cumene is isopropyl benzene, also known as cumene. So we have chloropropane, react it with AlCl3 and get isopropyl benzene. Okay. Now this isopropyl benzene, which is called cumene, is reacted with oxygen. Now when we react it with oxygen, and we don't add any extra thing, we just bubble air through the solution. So कुछ extra expense नहीं है कि oxygen कहाँ से लाते, air bubble करते हैं. Now oxygen by molecular orbital theory is a biradical. So this is the best radical site. We get a cumene hydroperoxide, OOH. Now when we react with H2SO4, protonation happens. Okay, like this. H2O gone. And shift of phenyl takes place. Right, migration. CH3 has lower migratory aptitude of pH. So pH is moving. See, this protonation happened and this pH is moving. So I'll have PHO, CH3, CCH3 positive. On this carbocation, water is attacking. So I will have hemiacetal. What is hemiacetal? When the same carbon is having OH and OR, then it is called hemiacetal. Okay, OH and OR, then it is called hemiacetal. If I protonate it, hemiacetals are unstable. Medium is acidic. We have H2SO4. So this is protonated. Phenol is released and we have formed this protonated acetone. Protonated acetone when release H plus and form acetone. Is that clear? H plus and acetone is formed. Is that absolutely okay? So net reaction is this: isopropyl benzene, oxygen, and dilute H2SO4, phenol and acetone is formed. Now you may have a question where different groups are present and we are asked what phenol will be formed, what compound will be formed. So by the mechanism, you see whichever group migrates, okay, whichever group migrates, that forms the alcohol. See in the last page, phenyl migrated, na? So it formed the phenol. Now, if there are different choices, how you can solve by shorthand? You simply identify out of the three groups which has the highest migratory aptitude. Now, yes, OME is appearing at ortho, but any group, whether electron releasing or withdrawing, if present at ortho position of phenyl, then it decreases its migratory aptitude. If the group is present at ortho position of phenyl, then it decreases the migratory aptitude, and thus, despite OME, this is not the group which will migrate better. Clear? Which will migrate? Phenyl will migrate. And if phenyl will migrate, okay, if phenyl will migrate, then I will have phenol as a product, and the rest part will just be ketone. Okay, you can apply this as a direct shorthand, no need to draw mechanism. Out of these, this has the best electron density, so we will migrate this. If I migrate this, then I will report this phenol and rest is my ketone. Is that absolutely okay? The product formed in the reaction of cumene with oxygen followed by treatment with dilute HCl-R. Now see how simple we have done, different groups present, then what will be formed. And what they are asking repeatedly is phenol, directly cumene par hi ban raha hai, what will be the product form? So as we have seen, it is phenol and acetone. Okay, they are asking it directly. Phenol and acetone is the answer. Now, important chemical properties of phenol, if we talk, of course, the acidic nature is the most prominent. Phenol is acidic, giving the reaction of this litmus test. Now, if I talk of H2CO3 dissociation, this particular, if I say pKa1, it is of 6.3. And if I talk of this pKa2, then it is, I think, 10.3 or so. Okay, pK1 and pK2, this is 6 point something, and this is 10.3. This I exactly remember. So, those particular acids which have the pKa1 less than 6.3 will displace H2CO3 from NHCO3 and CO2 gas thereby will be observed, brisk effervescence with NHCO3. But those which do not have pK1 less than 6.3 will not liberate CO2 from H2CO3. That is a general thing. Strong acid displaces weak acid. So that condition need to be met. If I say that a compound do not displace H2CO3, but can it react with Na2CO3 and form NHCO3? Yes, those compounds which will have pK less than 10.3 will react or will dissolve in Na2CO3. Okay, now see, phenol has pK roughly 9.95 or 10, we can say. So phenol will not react with NHCO3 because its pK is greater than 6.3, but will be reactive towards Na2CO3, form the salt, release NHCO3. But NHCO3 will not give CO2. CO2 will be released only when NHCO3 is further displaced to to H2CO3. Is that absolutely clear? So that is why, remember this, phenol is not soluble in NHCO3, but is soluble in Na2CO3. These are the phenols which liberate CO2 because their pKa is less than 6.3. For phenol to be able to give this reaction, nitrophenols, there should be presence of at least 2 nitro groups on phenol. Like this. 3 nitro, even better. Okay. 2 nitro, 1 OH. So here we were. So PHOH say, I was telling sodium, NH, NH2, NaOH. In सबके साथ तो we will have sodium phenoxide formed. With NHCO3, we will have no reaction. With Na2CO3, we will again have reaction. These are the acids whose pKa is less than 10.3. If you have one NO2, then its pK is nowhere less than 6.3. So for them, you will not have liberation of CO2. Okay, reduction of phenol. This is extremely important reaction, reduction of phenol. Direct with zinc dust, you can have benzene. But if you do it with metal hydrogen, OH is not gone. It is the ring which loses its aromaticity. Okay, so it depends on what reagent they are mentioning for reduction of alcohol or phenol. As per that, you will give the product. If we talk of oxidation, oxidation, important that phenol on KMnO4 oxidation will give total ring rupture. It will break into pieces. Okay? Phenol is totally broken into pieces. If we talk of Na2Cr2O7 or H2SO4 or air oxidation, then we have benzoquinone. This is important. We have already talked of phenol oxidation in air, but with Na2Cr2O7 or air, both we get this. Riemann-Tiemann reaction extremely important for phenol. Already we are having selective and important reactions. So if we have chloroform KOH, then carbene is formed. And this carbene, when attack on ortho and para position of phenol. Now see, it is not phenol which reacts in Riemann-Tiemann. It is the phenoxide which reacts. Right? It is the phenoxide which reacts. So there is no formation of carbocation. Right? There is no carbocation. It is rather a carbanion which is formed as an intermediate. Right? And then tautomerize. This is the intermediate. Again, 2 moles of NH come. Chlorine is displaced and aldehyde is formed. We can have para product also, but the major product usually is the ortho one. And minor product is the para product. Okay. Ortho product is the major product. Now remember orthonitrophenol, salicylic acid and its para isomer, para-nitrophenol. These set of ortho para isomers whenever formed will always be separated by steam distillation. Separated by steam distillation, and the one which have intramolecular H bonding will go with steam and other will remain behind, and that is how steam distillation is used. Okay, similar reactions. Phenol when react with CCl4. So phenol goes to phenoxide and then attack on CCl4. Now this time you will not have any carbene involved. Direct attack on CCl4, SN2 attack of phenoxide. Again, it is not attack of phenol, attack of phenoxide. Then you have COOH formed. If I have a direct attack of phenoxide, see O minus double bond, Cl. So when this attacks like this direct, SN2 type reaction takes place. Okay, we have this O and H, CCl3. Again, tautomerize. So you will have OH double bond, CCl3. Now 3 moles of OH minus 1's attack. 1, 2, 3. So what will we have? OH, C, OH, 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 1, and you will have salicylic acid. Right? So this is how salicylic acid is obtained by this method. Okay? Similarly, para product, but again, major is ortho product which is formed. Then we come to Kolbe-Schmidt reaction, in which phenol in basic medium, it means again phenoxide, is attacked by CO2. Like this, direct attack. So you have a salicylic acid. Salicylic acid is a precursor of aspirin. So very, very important. And precursor and just, you can say the basic or the starting material for aspirin formation. When we treat it with CH3, COCl, or you can have acetic acid anhydride, then in presence of pyridine, or I should say concentrated NaOH. It should not be totally dilute NaOH, otherwise hydrolysis of acid chloride will take place. Yesterday also someone asked, so I said don't take NaOH in general, dilute nahi lena. So this Cl gone. And we have OCOCH3, acetylation of this N takes place. This is aspirin. This aspirin is a white solid and it is water insoluble. So you will obtain it as a precipitate. Water insoluble. So we are obtaining it as a precipitate. Okay. Now what is found that in this Kolbe-Schmidt reaction, if okay, if NaOH is used, then ortho product is major product. Ortho product is major product. But if KOH is used, okay, then para product is major product. Please remember that with NaOH you will have ortho product. Why? Because of this intramolecular six-member chelation formed here. Now, sodium is a smaller size. It has a more strong polarizing power. So it polarizes CO2 towards it, and CO2 when come to close to ortho position, ortho products are major product. Okay, but if it is not so, it goes to para position. See the intermediate X in the following reaction: chloroform, KOH, X, NaOH, and water. So after NaOH and H plus, they are getting aldehyde. So definitely before here was CHCl2. Correct answer is C, not B, because in presence of NaH, phenol will always be reported as phenoxide. And we have the option, then we should prefer this one. If we talk of the basic electrophilic aromatic attack on benzene, so halogenation, डायरेक्टली बेंजीन पे हम ब्रोमीन डालते हैं तो हमें FeCl3 की प्रेजेंस में ब्रोमीन अटैच होता. But phenol being activated, we don't need FeCl3. Already ring is activated. If you take the reaction in CS2 solvent, which is less polar, then you will get orthobromo and parabromo phenol. Okay. But if you take bromine water, then you will get 2,4,6 tribromophenol as your product. Now see, this 2,4,6 tribromophenol is a white precipitate. So if I am getting a white precipitate, I will use it as practical organic chemistry POC for the use of reaction for conformation of phenol. Correct? Yes. If I want to make ortho only, then I should place SO3H or COH para to OH. So my plan may be that now I do bromination and I will get only ortho product. But the problem is that there is some reaction called ipso. So we again get 2,4,6 tribromophenol. Clear? And this is why, see, para-hydroxy acid. So even salicylic acid, if you take now for this reaction, you will get 2,4,6 tribromophenol. The difference in the reaction of phenol with bromine in chloroform and bromine in water medium is due to, now bromine in chloroform is definitely bromine in CS2 type you have to take, and bromine in water. So is there a hyperconjugation in substrate? No. Free radical formation? No. Electromeric effect? No. It is the difference of polarity solvent that gives you different product. Right? Now, I just want to make this emphatic note that these two reactions are asked so many times. Identify the major product A and B in the following. Bromine in CS2, 273 Kelvin. Ortho para mein se major will be para. Okay, because said na major product. And chloroform and KOH mein, if I talk of major product, then as we have discussed, this is Riemann-Tiemann. Ortho product will be major, so answer is 2. Okay. Very important, nitration. Nitration is again an important topic of phenol. See, if I do dilute HNO3, say I will get mononitration. Just orthonitrophenol and paranitrophenol, steam volatile. This is steam volatile, and we can do the separation by steam distillation. But if you take concentrated HNO3 and that too at 0 degree centigrade, then you will have picric acid, which is pK less than 1. It is basically 0.38. ठीक, इतना होता है इसका pK. So highly acidic. It is a yellow color compound. Nitro group is characteristic of yellow color compound. More the count of nitro groups, more will be the yellowness in that particular compound. Okay, so but the yield is poor. So now it is prepared as follows. Now we do not prepare picric acid by this method. What we do is we add concentrated H2SO4. And remember, you have to form disulfonic acid, 2SO3H, because NCERT has given this. And then you put concentrated HNO3. So ipso, these two are gone and one extra added. So this way we have much better yield of picric acid rather than this method. Clear? Now see how it is asked. Concentrated HNO3 and concentrated H2SO4 directly it is asked. So you have to identify the site. Most activating is OH. This is not a position because 4 continuous cannot be formed. So it will go para to OH. So this is my site of attack of NO2 and answer will be 3. Such direct questions can be expected. Next comes to the ester formation reaction of phenol. Now as all alcohols can form ester, right? Alcohols can form ester, that we all know, right? So phenol is also an acid. Phenol is also an OH group. It can also act as an acid. Like this, we have ester formation. The reaction is called Schotten-Baumann reaction. You can have anhydride and can form ester. You can have acid chloride and ester. Any of these you can use. Okay, and you can form ester. Acid chloride when it is, then it is very essential to use pyridine or 3-degree amine in a medium to absorb this HCl. Otherwise, this HCl will have its own pace of some different reactivity and we will lose the reaction. Clear? Again, this salicylic acid reaction is written here. So you are getting aspirin, which is white, analgesic यानी पेन किलर, एंटी इन्फ्लेमेटरी यानी जो इन्फ्लेमेशन इन बॉडी को डिक्रीज करती है, एंड एंटी पायरेटिक. This is something you have read in chemistry in everyday life. If in place of alcohol we use RNH2, then we will get this type of amide, RCONHR. Is that clear? Then you will have RCONHR. Till here, no problem. POC of phenol, important, very important, acidic nature. It turns blue litmus red. It is soluble in NH, soluble in Na2CO3, but insoluble in NHCO3. Neutral FeCl3. Now, here I want to use some other things. So just wait, neutral FeCl3. Bromine water test. Phenol with bromine water will form 2,4,6 tribromophenol. Phthalate dye test and all these things I want you to take from NCERT directly first. So let me share the NCERT page for you. Oh, acha, I had opened it before, but actually light जाने की वजह से it got closed. Let me share the screen. Stop share. Yes. Now you can see this, like whatever written there, but what are the possibilities? POC is important this week, na? So for alcohol, it is steric ammonium nitrate, iodoform test, all these things are given. Coming to phenols, phenolic group. This is the NCERT lab manual. I hope you can see it all properly. See, the OH group attached directly to the ring, carbon of an aromatic ring, is called phenolic group. Phenols are weakly acidic, therefore they are soluble in NaOH solution, but at the same time they are not sufficiently acidic to be soluble in sodium hydrogen carbonate. Okay, so it is not soluble there. Correct? But is soluble in NaOH. Phenols give colored complex with neutral FeCl3. Now see the colored complex. This PHO, this part, not H plus, PHO 6 times Fe3 minus, violet color complex is formed. Okay? Now phenol is giving a violet color. Read the rest. Resorcinol, orthometa and paracresol give violet or blue color. Cresol बोले तो ring, उस पर एक OH and there is some CH3, ortho, meta and para. Catechol gives green color which rapidly darkens. What is catechol? Catechol is 2OH. Then it is called catechol. 1 and 2 nephthol do not give characteristic color. If I talk of 1 and 2 nephthols, then they do not give characteristic colors. Phenols condense with, so this was the FeCl3 के साथ. Important note ये, अगर आपके पास नहीं है तो ये NCERT लैब मैनुअल से प्लीज इसे यूज करें, लिखें. फिनॉल सेकंड टेस्ट शुरू हो रहा है. फिनॉल कंडेंस विथ थैलिक एनहाइड्राइड. Phthalic anhydride. In the presence of concentrated H2SO4, phenol condenses to give phenolphthalein. Okay, phenolphthalein is formed. Very good. बढ़िया बात है. But how to have the mechanism of phenolphthalein? I think now you can see. Yes. So I want to give you the mechanism of phenolphthalein. If I talk general, this we have done, bromine water we have done. So here phenolphthalein. In general or a net reaction, you simply write this way. Phenolphthalein is formed. That is the best method. If you want mechanism, then all I can say is it is EAS reaction, electrophilic addition reaction. See, phthalic acid anhydride is like this. And when we add H2SO4, any of its carbonyl is protonated. And phenol, when attacked by such big electrophile, it will be attacked at para position. So OH, right? OH, para pe, we will have C, OH, O, like this. Agreed? Now, this is not going to be like this. Leaving group you will observe. Ultimately, it will leave. So, here I will have C double bond O, para position OH, CO, OH. Condition is acidic, so I will not leave it as COO minus. Again, medium is acidic. And ketone is more basic than carboxylic acid. So again, protonation here. And if protonation here, phenol, next molecule, will again attack from para position here. Okay, so what I will get, check. Ring C, OH, 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 and COH. Now acid plus alcohol will form ester. Conditions are suitable for ester. So we will close the ring again. Carbon, OH, OH. This is how we get HPH phenolphthalein. This is phenolphthalein. Now about this, see this phenolphthalein we have talked of. This is what is it? इस तरह से बनती है. Okay. Now under basic condition, what happens? That this OH will lose H plus and will form this type of anion. And it is a dianion. One of the ring, if resonates, then ring opens. This dianion is pink. Okay, this dianion is pink. If I increase the basicity, it forms a trianion. And this trianion is colorless. This trianion is colorless. And therefore, phenolphthalein shows color pink in a limited range from 8.5, I think, to 10.5. Na? It do not show color pink in highly basic conditions. If I increase the pH further towards 14, I will not get the pink color. So it is a particular range where it shows color. If it is neutral, then it will also not show color. Like this is colorless. This is colorless. Color comes with this dianion. Okay? if para position is blocked, then this test fails. This is again from NCERT. I have taken. I will share the NCERT page again. So para position is available. Orthocresol give red color. Metacresol give bluish purple color. But para, if it is, then para position being blocked. In phenolphthalein test, there is no color. In FeCl3, there was color. All these cresols gave color in FeCl3. So read the question carefully. Catechol gives usually blue, takes longer time to appear, but ultimately it gives the phenolphthalein test. Resorcinol gives the green fluorescent color. Phenolphthalein to aa raha hai na? Quinol, para position blocked, no color. Okay, so this para blocked condition is only for phenolphthalein test, not in general. Okay, so that is not a general property that every time you will have this particular behavior. Is that absolutely okay? And as I said, I took it from NCERT. I'm taking it again from NCERT. See this. Orthocresol, red. This table only I changed to this my handwriting work. Otherwise, this is an NCERT table. Okay, same thing I have taken. Bluish purple, no color. Whatever they have said in names, I have taken the structure also. So it is same. Okay. In FeCl3 also we have taken from here only. Whatever we wrote was from here only. Going further. So dye test. Now what is a dye test? We take diazonium chloride and phenol. But see, we have to take phenol in alkaline medium. Yes, Giteshwar? Tell.
Ma'am, in the phenol dye test, what if like I have to make substitution in such a way that I get three continuous thingies? Will the reaction still occur? Yes,
Yes,
ma'am.
Giteshwar. Huh.
If I have one of the para positions blocked in such a way that if I have to do the dye test, I have to get three continuous substitutions. Will it still occur? Because that reaction is relatively like it doesn't occur.
I don't know what you said. I could not understand what you said. Can you repeat? If
Let's
you
take
have
toluene, like
toluene,
toluene with like two hydroxyl groups connected side by side.
if I have a toluene and two
And
hydroxyl group like this. Okay, so you are saying कि para position is sterically crowded.
yes, ma'am.
I guess then the test should fail क्योंकि इतना बड़ा मतलब though it is a hypothetical assumption, we have not seen any such compound in general. But yes, ideally it should fail because of the lot of steric.
So
Search of
if
a para is in itself for steric only. We are searching para for steric only. So if it is not available, then it should fail.
okay, ma'am.
Okay, that is it, Kiteshwar. Okay. So we were doing this. So Thalin dye test we have done, and dye test we were doing from our notes. So I was telling कि aniline when treated with NNO2 plus HCl will form diazonium. This is a very general basic thing that all of you know. Now, when this diazonium is made to treat with phenol under alkaline condition. Why under alkaline? Because phenol do not react with diazonium. We need phenoxide to react. Always phenoxide. For phenol, diazonium attack may fail, but phenoxide पर होता है. So phenoxide पे when para position attack is there, you will get an orange color dye. Bipasha Roy. This is beta naphthol. This beta naphthol, and see the site of attack of diazonium. Okay, because alpha position is what is attacked. You will have a rosy red. So beta naphthol, red. Phenol, orange. Aniline, when we react, then we get yellow. Right? So it is Bipasha Roy. Remember this. Now the questions ask which of the following compound will give pink color on reaction with phthalic anhydride. Will give. So we are searching para position available. See, this type of question has appeared. Para position block questions appeared. But what just Giteshwar asked CH3 ki two sides OH, that has not appeared. Okay, so but here these type have appeared. Next is an organic compound gives dark green coloration with FeCl3 chloride. Now see, it is saying dark green color with FeCl3. on treatment with chloroform and KOH followed by acidification gives compound B. Compound B can also be obtained from compound C on reaction with pyridinium chlorochromate, right? So B can also be obtained from C by pyridinium chlorochromate, right? That is there. So this cannot be because C cannot oxidize by PCC and give this. So these two though by this last line only failed. Third and fourth option are deleted. Now coming to A and 2, the only point of difference is C to B. CHO cannot be oxidized to CH2OH. CH2OH can be oxidized. So even without solving the question, answer became first. But the problem with this question was that gives dark green color, whereas we just read in phenol, right? हमने अभी करा है question. Sorry, reading from neutral FeCl3, and it was not that dark green color नहीं था neutral FeCl3 में. See, violet complex is mentioned. The green color was of catechol. So there was this error here, but we had to go for this option. We didn't have any choice. Catechol gives green color. Phenol do not give green color, but the choices were only of phenol. Okay, so that is what I say. Ki select the best. You cannot stop the question what green coloration. ठीक? Oxidation has been asked. That is what important. A very, very simple question, but good question. List 1 with list 2. Phenol to CHO, what reagent? Chloroform and NaOH. Phenol to benzene, zinc dust. Phenol to benzoquinone, Na2Cr2O7. And parabromo is first, Br2 in CS2. Answer is A. 4, 3, 2, 1, 4, 3, 2, 1. Okay, so that brings us to the closure of phenol. Now, in case of ether, we have some important reactions. So we'll mainly go to that, starting with some basics. If R and R dash are same, alkyl or aryl, then ethers are called simple ether. If they are different, then it is called mixed ether. Simple ethers are also called symmetrical ether. Mixed are called unsymmetrical ethers. Now see, MEO-ME if I take, then the bond angle is 111 degrees. Okay, 111 degrees, it is slightly greater than this 109 degree 28 minutes. उससे थोड़ा सा बड़ा है. ठीक. Preparation of ethers by dehydration of alcohols. If you go for 140 degree, you have diethyl ether. If you have higher temperature, you have alkene formed. At lower temperature, ether is formed. Yes, that we have done in long time back, hydrocarbon chapter. You can prepare it by Williamson, right? Alkyl halide, alkoxide. But you have to maintain alkyl halide to be maximum 2 degree, 1 degree, 2 degree, 1 degree, 2 degree. If you bring 3 degree, then you will not get ether. You will get alkene by E2. Right? You cannot get ethers by aryl halides, vinyl halides. These type of problems will be there. You can have phenoxide and get phenyl ether. Right? You can have SNAR. यहाँ हेलोजन लगा है, SNAR से रिएक्शन हो जाए, that is a possibility that you can take. Okay. Now the question was, if I have to prepare this, which is the good combination? Now there are two possibilities. Either I take a tertiary butoxide on ethyl halide, or I take a ethoxide on tertiary halide. So definitely A will be better. Because if I take this 3 degree alkyl halide, it will not be SN2. It will be E2. Alkenes will be formed. If I talk of physical properties of ether, yes, they have dipole moment. They have very weak dipole moment and show some polarity, but not comparable to alcohols or similar compounds that we have seen before. Okay? So they have slight polarity, but not capable of H bonding. So their boiling point is close to alkanes and very less than isomeric alcohols. So you have N-pentane. This is important. And diethyl ether. So their molecular weight is pretty close, but unexpectedly the boiling point of N-pentane is slightly higher than diethyl ether. Okay. Then we have butanol, which is much, much greater, 390C. This is given in NCERT, remember that. Water solubility is quite close to alcohols because they anyhow form H bonds with water. And they are acceptor of H bonds. Reactions of ether, that is why we entered into this. Two reactions you have to remember. One is with HX, one is with dilute H2SO4. Now see, ethers are not reactive in alkaline and neutral conditions, open chain ether. With concentrated HX, HCl do not go for fission, HIHBr do. What is the mechanism? First, we protonate ether. Let me assume R dash is smaller. So if I minus attack by SN2, I will get R dash I. If attacked by SN1, I'll get Ri. Now the point is, what is the mechanism? What is the attack method? So if both R and R dash are 1 degree or 2 degree, then SN2 mechanism is observed. Both R and R dash. But even if one is benzyl, allyl or 3 degree, then SN1 is observed. If HI is taken in excess and temperature are high, then alcohol also react with HI and alkyl iodide is the final product. Ri are formed. Is that clear? See, give products. You will break, okay, and you will decide on the basis of C methyl ethyl, both primary. It is SN2. If it is SN2, then I minus will go to smaller one. MEI is formed. If 2 degree and 1 degree, okay, I take 2 degree and 1 degree. Then again SN2 only, because we said benzyl agar hoga, then only we will have this SN1, benzyl, allyl, 3 degree. So here you will have SN1. And so the iodide is PHCH2I and phenol. Is that clear? How we decide? If I have both sides PHOH, now as even if I protonate, both sides I am having aromatic rings, and aromatic rings are not good for either SN1 or SN2. So I will not have a condition of no reaction. Okay. So we are having a condition of no reaction. Is that absolutely okay? If I have a tertiary butoxide and this, see, now it is a 3 degree group here. So if I am having a 3 degree group, I will now have SN1 mechanism and SN1, and therefore I minus will attack on 3 degree. So tertiary butyl iodide is formed. Is this absolutely clear? That if both sides are 1 degree or methyl, then your answers are by SN2. But if any side is by 3 degree allyl benzyl, which can form stable carbocation, then your answers change to SN1. Is that absolutely okay? So these type of questions are asked. HI to give hydroxy compound, which is further heated with zinc, to give compound B. Identify A and B. See, concentrated HI. Phenol cannot go further. Phenol cannot react with HI any further. So whatever comes here will be stopped there itself. So phenol and isopropyl iodide. Now zinc dust is there, so B will become benzene. Right? Again, the similar, the major product. It is good for SN2 because cyano ka alpha position, phenyl ka alpha position. So I will have iodine here, alpha to cyano electron withdrawing group, right? And this is alcohol. This is anyhow phenol. So answer is A. Okay. Same thing again asked, HBr, so we'll break and then intramolecular Woods reaction is taken. When we come to dilute H2SO4, now dilute H2SO4 is simply meant in cold conditions. Then there is no reaction. You will not have any reaction with dilute H2SO4. Okay. Dilute H2SO4 will just dissolve the compound. Is that absolutely okay? With dilute H2SO4, you will not have any such reaction. You will just dissolve the compound. But if the reaction is dilute H2SO4 and heat, then we will have a reaction. What is the reaction? Now see, water is a weak nucleophile, so it will prefer SN1 reaction. Iodide or bromide were strong nucleophiles, so they were preferring SN2 reaction. With water, what you will do is you will protonate and then you will decide what alkyl. If both R and R dash are 1 degree or methyl, only then you will have SN2, otherwise always SN1. Only when R and R dash both are methyl and 1 degree, then only you will have SN2, otherwise always SN1 reaction. But protonation is a must. So see, give products. So which side it will break? Now both are 1 degree. So if I attack water from outside, I will have SN2. So here I will attack after protonation. So ethanol will have the O18. That is why the answer is this. But if Na is 2 degree, then the thing become SN1. So here water will attack. So O18 existing goes with isopropanol. 3 degree. So tertiary butanol. No reaction. Very important here. See O18. So it is not that ring breaks, this breaks first. First you have an electrophilic addition of water. Hemiacetal is formed. Then we remove it like this. So O18 went with ethyl. If you go just by that it is a vinyl, you may do it wrong. Okay, so it goes and your aldehyde formed is of non-O18 material. Absolutely clear? So open chain ethers do not react under basic condition as RO minus is a bad living group. है ना, ऐसे अटैक करके हम RO minus नहीं हटा सकते. But 3 and 4 membered rings which are strained, they will react under basic conditions, neutral conditions, and their reactivity is SN2. So less hindered positions will be attacked. Take like this. If acidic conditions you take, then follow whatever we did just before. So if I take concentrated NaOH, I will attack OH minus. Okay, I will attack OH minus like this and we'll have attack. If I take R minus, see this type. Same is with oxygen, less sterically hindered is attacked. If you attack with PPH3, again SN2, ring open, 4-member ring forms, strained, breaks, ethene is formed. This reaction you check with ammonia excess. Repeated attack on one oxygen, then second, then third. With oxygen excess. So you have got this type of alcohol amine. Okay. Cyclic ethers also undergo the same fission. Same. You check what is the degree, what is the reagent. Iodide, strong nucleophile. So SN2. But this side is 2 degree and 1 degree. So with 2 degree, 1 degree SN2, so I'll have iodide at 1 degree. 3 degree and 1 degree, then SN1, so I will have iodine here. Right? If I have this type of structure, dilute H2SO4, as I have just shown you that it is first addition of water and then it breaks. So O18 is going this side and this remains double bond. If it is alcohol, then it is acetal, OR. So no further reaction. Now this is a tendency of ether that oxygen co-adjacent position is a good radical forming site. So if I have oxygen, this alpha position is attacked by nascent oxygen. Hydroperoxy ether is formed, which is explosive. If I take FeSO4, then Fe3 plus is formed. Right, with KCN it forms FeSCN whole thrice. So this is used as a POC that yes, there is oxidation happened for alpha positions. And this can also be used as a method, like this oxygen is gone and ether is regenerated, because ether is a common solvent in lab. If it has formed this particular hydroperoxy ether, then we may have explosions in the reaction. So it is important for us to have this reaction. Is that clear? ठीक? And that closes our today's session. So anyone who has doubt can ask doubts, other can start leaving. Raise your hand, I'll let you ask the doubt. Okay, so we have Ashish. Yes, Ashish.
Ma'am, my
I,
doubt is regarding today's PTM paper. Ma'am?
I don't have PTM paper. I'll
Okay.
try to help if you can give me the question.
Okay. The number of alcoholic isomers possible for C4H10O.
Ek second. So it is given alcoholic, not phenolic.
Yeah.
And
C4H
C,
C4H10O.
okay, CnH2n. So it is fully saturated, CnH2n plus 2,
Yeah.
right? And nothing
Yeah.
else regarding stereo, Ashish?
We doesn't consider stereo, ma'am,
Why?
because they doesn't mention that excluding stereo.
When it is not mentioned excluding stereo, then understood that you have to include stereo.
Okay. I
Okay,
got
these should be
I got
choices of
5.
no, these are the structural, na?
Yeah.
And then this is chiral. So
Yeah.
answer should be 5, it seems.
Answer in the key they given as 4, ma'am. So that I asked.
You put objection. Can
Okay.
you read the question again?
The number of alcoholic isomers possible for the molecular formula C4H10O is.
Yes, put the objection to 5.
Okay.
Okay.
Okay,
When
ma'am.
they do not, now, when they could have given answer 4, number of structural isomers possible for the formula C4H10O, alcoholic isomers, then they can put answer 4. Or they could
Okay.
have given the bracketed that excludes stereo, then answer is 4.
They
If they
doesn't
have
give.
mentioned either, then the answer will be 5, Ashish.
Okay, ma'am. Thank you, ma'am.
Okay, you can forward it.
Mm.
Yes, Meher?
Ma'am, in phenols, the preparation methods by cumin,
Yes.
if you have paracresol and phenol, which one we prefer?
Which one will
In like the perox
migrate?
for migration, if you have choice between paracresol and phenol, which one would lead?
बेटा पैराक्रेसॉल कैसे होगा बिकॉज ये सी तो ऑलरेडी अटैच है सो इफ आई हैव OH like how could it be paracresol as a group attached?
It was a question today.
But you have to tell me the exact structure or take help
Yeah,
of Ashish. He has paper in hand, I guess.
1 minute.
Either you tell the exact question because paracresol not possible. Ashish, I allowed you to unmute. If you
Yeah.
have paper in hand, please help about
Which
what question
question?
is.
1 minute. 1 minute.
Question number he doesn't remember. He's saying there was a question of cumene hydroperoxide migration.
Yeah, yeah, yeah.
Some group
It's
was there.
33. Yeah, pH.
pH. One is pH. What is other?
Other is taurine, which is in para position.
So
Is
check. Is this
Yes, ma'am.
and what is the third group?
Uh, think it's
CH3.
Just CH3.
Yeah.
So which group has the maximum migratory order, Meher?
okay.
This
Tolerant.
one,
Yeah.
right? And we just talked of a shorthand that whichever migrates will form the phenol. So answer is paracresol. And the other part will remain as ketone. Like this.
Yes, ma'am.
Is that okay, Meher, now?
Yes, ma'am.
Okay. Anyone else? Raise your hand if anyone else has a problem. No one? Okay. If no one has a problem, let's end the meeting. Oh yes, Dhriti has a problem. I have allowed you to unmute, Dhriti. Please unmute.
Uh, yeah.
अरे अरे धृति फिर से म्यूट हो गई, एक बार फिर से करो.
Yes, ma'am. My
Dhruti,
question
you
is,
are from Bangalore, na?
me here. Yes, ma'am.
And last week I told you SN1 stereo specific or not, I'll let you know.
No, ma'am. No.
Not that, Dhriti? Okay, confused. Okay. So tell me what you were asking.
Ma'am, salicylate ion is a weaker base than parahydroxybenzoate or something.
Let me check first what you are saying. Salicylic acid. Salicylic
Uh,
acid like this.
yes, ma'am.
So full acid I should make, na?
They mentioned ion.
Iron. So I think then probably this is what it is.
Hmm.
है ना? And what
Yes,
was the
ma'am.
other compound?
Parahydroxybenzoate.
पैराहाइड्रोक्सी बेंजोएट, तो वो ऐसा हो जाएगा बेटे. अब एक बार क्वेश्चन पढ़ दे.
Salicylate ion is a weaker base than parahydroxybenzoate.
मतलब केबी का ऑर्डर ऐसा होगा, राइट. वीकर बेस मतलब इट शुड एब्जॉर्ब H प्लस लेस इफेक्टिवली. हाँ धृति, ये बात तो सही लग रही है बेटा, क्योंकि ये देखना डेल माइनस, तो यहाँ बढ़िया एच बॉन्डिंग से स्टेबलाइज्ड है ये.
Okay.
नायन इंट्रामोलिकुलर एच बॉन्डिंग से, यहाँ ऐसा नहीं है. सही.
Okay. Thank you, ma'am.
आगे समझ में बात में. ठीक.
हाँ, हाँ, ma'am.
ओके.